So chapter number 2, chemistry. So it's your introductory class today. What are we going to do? What are we going to do? We'll be starting with the liquid state, right? And which is the liquid state over here? Behavior of liquids, diffusion, compression, expansion, contraction, viscosity. If you remember, gases, the same topics were there, but this time we will be studying under the heading of liquids. Okay. So today we'll be covering diffusion, compression, expansion, contraction. Next topic would be viscosity. All right. So what do you mean by the liquid state? A very uh, childish question. It's a state of matter. It's a state of matter which do not have any definite shape, but fixed volume. Right? So liquids have fixed volume, but no fixed shape. So here are some properties of liquids. The first one is, you can see over here, what's going on? Mixing, diffusion. It means liquids are diffusible. The molecules of one liquid are mixing over here into the molecules of the other, right? And here is a term written there, miscible. Miscible. What do you mean by miscible? Miscible means having the same nature. You can't mix oil and water because they are immiscible. They have different nature. But you can mix syrup in water, etc. Why? Because their nature is same. So liquids are diffusible into one another, or you can say liquids of the same nature can diffuse into one another. And what is this? What is the reason behind it? Because the molecules of the liquids have spaces among them. So the molecules of one will mix into the molecules of the other. If we compare the rate of diffusion of liquid in gases, then the liquids are slower in nature, whereas gases diffuse very fast, right? For example, if someone sprays over here, within a second, it will reach to some distance. But the speed of liquid molecules, they are slow in nature because they have less energy. They are being more attracted by the neighboring molecules. All right. So when a drop of ink is added to water, the whole water develops the same color of ink after some time because just of diffusion. How does KMT kinetic molecular theory explains this phenomena? Why this mixing can take place? Because the particles, the molecules of the liquids are in motion, so they mix with each other. Secondly, they have spaces among them. That is where the diffusion is possible. Clear? The molecules of liquids are in limited motion and are closer with each other. Closer, not compacted, not 100% compact. They have gaps among them. So in these gaps, the molecules of two liquids will mix each other. Okay. Another video regarding this mixing. The molecules of the same nature, molecules of the same characteristic are mixing over here. Here we will show you what is the effect of temperature on mixing. All of you must have observed that it is easy to add sugar in hot water than in cold water. So same over here, we have two different things. One is the hot water, the other one is the cold water. And you can see in hot water, the mixing, the diffusion of ink is very fast. It's done, almost done. Whereas in the cold water, it is a little bit slower. So what is the main point over here? If at high temperature, or the diffusion of liquids would be more. Why? Because the molecules of liquids have more energy, more velocity, more kinetic energy, so they will move with a faster rate. Okay. Next is compression or compressibility. Gases can be compressed because they have large empty spaces among them, right? They can be compressed very easily. Like we have this body sprays in which the gas molecules are being compressed, right? We have CNG, the same. But the molecules of a liquid are already so much compact, so much closer to each other. They can't be further compressed. That is why sitting here, generally liquids are incompressible. Generally, the liquids cannot be compressed. But if we apply very, very high pressure, like very, very high pressure, then they could be compressed little bit. Okay? So, compression in liquids, 2 points. Under normal condition, they can't be compressed. Means it's not possible for us to compress 1 liter of milk into 1 glass of water, into 1 glass, no. Or we are having 1 liter of Pepsi and we just compress it into a small glass. No, 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 never, right? So that is why we say liquids are incompressible. But there's a term, recall the knowledge of physics previous grade. When we apply pressure on a liquid, liquid transmit that pressure forward, right? Suppose there is some water in a bag, um, in a shopper, or in a, right, and you just squeeze it. You are compressing it like this, and it will transmit the pressure. The garden pipe, the hose pipe is there, and someone stepped on it. The pressure, the leakage would be increased, right? So this is called Pascal's law. You have done it in physics. I'm not explaining it in detail because I hope that you have already understood it. Just mention the third point, mentioning you the third point. What is that point? That if pressure is applied on a liquid, the liquid will transmit that pressure in different directions, right? And on this hydraulic brake system or different other processes can be observed. I already told you that why liquids are incompressible, because there isn't much space among them, among the molecules. Simple topics. Hoping that you already know diffusion, compression, etc. of gases. Expansion, another childish topic. What the topic is expansion, you know that when something is heated, it expands. Same is true in case of liquids. Most common example is thermometer. In thermometer, we have mercury. When it is being heated, what happens? The level of the mercury raises, and when it is cold, it contracted. So, what is the point over here? The liquids expand on heating and contract on cooling, right? When you heat a substance, it means it's an endothermic process. Endo, exo, there are two processes. Endothermic means a process in which heat is being absorbed, like cooking is an endothermic process, right? In this case, heat is being supplied to the food enters into the food means endothermic process, and exo in which heat is given out. So expansion, in expansion what happens? Heat is being transferred to the mercury, heat is being transferred to the liquid, and it expands. When it is being transferred to the liquid, what happens? The energy, the kinetic energy of the molecules of a liquid rises, increases, and molecules will start moving with a greater amplitude, and this will result in expansion. Right? So what is expansion? Increase in volume on heating, it's called expansion, and all liquids expand. First thing, why is this so? Because when we supply energy, when we supply heat energy to the liquid, the molecules will have more energy. They will move to a greater value. Greater value means they expand, right? And since heat is being absorbed, that is why it's an endothermic process, right? And what is contraction? Just reverse all of these points. Liquids contract on cooling. It's an exothermic process in which heat is being given out. Kinetic energy of the molecule decreases. Kinetic energy decreases. Initially, the molecules will be moving like this. Now, kinetic energy decreases, they will move like this, needing less space. Less space means contracted. So, liquids expand on heating, contract on cooling. All right. So that's all for today. Next, what will we do? We'll start with the revision, and then we'll see the next topic, viscosity.
Thank you so much. Take care. If you have any question, ask afterwards.